Okay, folks, what we're going to be looking at today, we're looking at probability tree diagram. So let's select a brush. Okay. Okay. All right. And we don't have a pen. Give me one moment. All right. In probability, when we use the word and, Mr. Fassa, what does it mean? So, and refers to times. Okay, and the O refers to plus. Hold on. Okay. So when we mention the word and in a probability question, we're talking about multiplying probabilities. When we talk about O, we're talking about adding the probabilities. Now, let's have a look at this nice, straightforward tree diagram here. Question number 12. Okay, it's probability. We got a die being thrown 2 times. I know this says dice, but it's actually first dice, second dice. Okay, in that case, we do have dice. We have plural, more than one. Now, the probability of getting a 6, I don't know whether you can just about see that there is 1/6 over here. Can you see that on your sheet? And there's one there. 1/6. Let's see if we can expand this a bit. Okay, that's actually better there. Okay, let's actually make this a bit smaller here. Okay. That's better. Now, let's choose a nice color, a bright one. Okay, probability of scoring a 6 on the first dice is 1/6, which is over here. Probability of getting a 6. Probability of not getting a 6 is 5/6. Yeah, because you got 5 chances of not getting a 6. Now, if this is repeated twice, this is the second dice combination over here. 6, not 6, 6, and not 6. Okay, so these events are they dependent on the previous thing or the independent? Independent. So the second event is independent of the first one. You can get the same thing all over again. So now, if you look at the tree diagram now, probability of me getting 6 will be coming along here and also along here. So we say probability of a 6 and another 6. To work out the probability of 2 6s, what do we do with the fractions? We times them together. So there's the calculation over here. Okay, now next one. If I want to look at the probability of getting a 6, probability of getting a 6 first of all, and then not getting a 6 is this particular path. But the whole point of having the tree diagram, you can follow a particular path and see the numbers that involve that path. So we got now 1/6, and also now we got 5/6. Can you see that at the back, Mr. Hassan? Yeah. So probability of getting a 6 and not a 6 is going to be 1/6. This first fraction multiplied by the second fraction. 1/6 times by 5/6 will give us 5/36. Now, the other two parts they've left blank. We need to fill that in ourselves. So, Mr. Hassan, try to stay awake, please. I know this is maybe not the most exciting thing you've done in the whole day. Yeah. So, here we go. Probability of not 6, first of all, this one here. Start here, down here. Probability not 6, and then probability of getting a 6. Here we go. P. Probability of not 6 and a 6. So what are the fractions involved here, Mr. Abdullah? The fractions are 5/6 and 1/6. So we do 5/6. Multiply that by 1/6, and that will give us an answer of, Mr. Hassan, what will that give us an answer of?
5/36.
5/36. Excellent. Okay, the last one. Now, if I want to work out the probability of not getting a 6 twice, so not 6 and not 6, so we write that down over here. So probability of not 6 and probability of not 6 again, so twice. So that's going to be, I'm going to go over it now in blue. So the same fraction here and this fraction over here. So that's, we're now going on the blue path. So what do we say? The probability, so what are the fractions, Mr. Saf?
4/6 times 5/6.
So we have 5/6 multiplied by 5/6, which gives us an answer of
25/36.
25 over 36. Okay, so that's looking at that particular question. I think that's question number 12. Are we happy with how we deal with a very basic question in terms of how we fill the tree diagram in, how do we write down the probabilities at the end, and things like that? Yeah, happy with that? Okay, let's try to find the next part of that question. I think I need to zoom out possibly and move the page around. So give me a moment. If we look at this next question here, the probability, the one with the even score and the odd score, we can look at the question on the bottom. Okay, to do with the British car and the foreign cars. Okay, let's have somebody read the question. Abdullah, read the question now. You can read it from your own page in front of you, or from there if you can read 2/3 of the cars. Start from there, please. Read it first, please.
Shall I read it?
Okay, you go.
2/3 of the cars on British roads are on foreign manufacture. Copy and complete this tree diagram to find A, P, the next two cars you see being British made. B, P, the next two cars you see not being British made.
Okay, nice straightforward question. Let's have a look at how we fill in the diagram. So let's choose a red. Let's choose them nicely. So, we have here 2/3 here. If this is 2/3, then automatically the top one will be 1/3, because each part of the tree diagram must add up to 1. Now, because it's independent of the previous one, so we're going to have here now also 1/3 and 2/3. So we have 1/3 and 2/3. So we can quite easily fill in this part of the tree diagram. Okay, now the question says the probability of the next two cars you see being British made. So I'm going to change color to an orange now. So British made would be where? So it would be this path, yeah, British, followed by British again. So probability of, okay, let's choose something a bit more dark over here. Probability of a British and the probability of British is equal to 1/3 multiplied by 1/3, which gives us an answer of 1/9. Because the next two cars you see not being British made. So what does that mean, not being British made? So what it's referring to in the diagram? Foreign. Okay. Alright, let's have a look. Alright, so I'm looking at this path here, followed by this path. So the probability of foreign and the probability of foreign is equal to 2/3 times by 2/3 is equal to 4/9. Okay, now let me throw in my own question now. What is the probability of getting at least one British car? Let's see how you understand this question. Okay, what does that mean? If I say probability of getting at least one British car, what does it mean in terms of how you look at the question?
Foreign and British, you'd have to times both of them, like fractions by each other, because you'll get one.
Yeah, and what else in the diagram?
1/3 times 2/3.
Okay, you give me calculation. Give me the. So, for example, could we have British? Okay, I'm going to use purple now. Can we have British and British?
No.
Yes, because it goes at least one British car.
Oh,
That means you can have two. So we could have probability of British and British. Okay, that's could be one. Or
British and foreign.
we can have probability of British and foreign. So probability of British and foreign. Or we could have probability of foreign followed by British. Isn't it?
But that's the second one.
It doesn't matter. Is one of them British though? It doesn't matter which order it is. The order doesn't matter here. Because the question goes, what's the probability of getting at least one British? So it doesn't matter whether the British is the first one or the second one. So we say probability of foreign and British. So now that's how we interpret the diagram, interpret that type of question. So it can be either one British car or two, and in any order. So now let's do the mathematics for that. Okay, so what's the probability of British followed by British? What is going to be? A third time by a third. What does the word or mean?
Add.
O means add. O means add. Okay, lovely. And what's the probability of British and foreign?
and 2/3.
Okay, let's go back to it. 1/3 and
2/3.
1/3 and 2/3. Okay, and probably foreign and British will be this one here. 2/3 and
1/3.
2/3 and 1/3. And what's the and mean, Abdullah? Again? And means? Look over here, I've just done there. And means times. 2/3, what is 2/3 times by? 1/3. Okay, off we go. Let's start looking at what's 1/3 times by 1/3?
1/9.
1/9. What's 1/3 times by 2/3?
2/9.
What's 2/3 times by 1/3?
2/9.
And what do we do with all these now? Add them up. So, what is 1/9 add 2/9 add 2/9 is? So the final answer is
5/9.
so the question there, by me changing the wording of the question, it means something else. So you've got to get used to the style of the words that are asking the question. Okay, right. Can you have a go with the stew one, please? Underneath.
On the
Yeah,
sheet.
On the sheet, yeah, on the sheet. Thank you.
So
Try to show us. Done? Okay. Can you try that one now, please? Answer the little question. Okay, recording here. Probability of John being reselected after winning tomorrow. So if we just look at this one here now. So it's got to win. So it's going to be selected, winning, and then
reselect.
reselected. So for that one here, the answer is going to be probability of selected and the probability of winning and the probability of reselected. So that gives us probability of 1/3 and means times 3/4 and means times, and the next one is a half. So you need to multiply all of these together. So 1 times by 3 times by 1 is 3. And 3 times by 4 times by 2 will give us 24. And if you cancel it down, that will give us what? 1 over
8.
8. Well done. Excellent. Okay. Next question. What is the probability of losing tomorrow with John in the team? So it's got to be selected, and then they got to, and then it stops there. So for that one, we're going to do probability of selected and the probability of then losing. So that's going to be 1/3 times by 1/4. That gives you 1/12. Okay. Now it goes probability that John will not be in the team tomorrow.
This is 2/3.
Just 2/3, and that's the end of the question. Because that one's reselected. Okay. Done. Okay. Has everybody had a go at the next one? Should we put some probabilities on there? Okay, right. Okay. The probability of going to the library on Saturday is 1/2. So probability of not going to the library is another half. Probability of borrowing a book is 4/5. So no book is 1/5. You take it back overdue is 3/4. So be on time is 1/4. Okay, question A. What's the probability of borrowing a book which runs overdue? So he's got to go to the library first of all, then borrow the book, and then it's going to be overdue. So if you look at it in terms of like a path, so it's going to be this one, followed by that one, followed by that one. So we can say, Mr. Abdullah, are you with us? Probability of going to the library and the probability of borrowing the book and the probability that it will be overdue. So the first probability is a half and means times. Borrowing a book is 4/5 and means times. Probability of overdue is 3/4. So we multiply out all the top numbers, Mr. Hassan. 1 times by 4 times by 3, which gives us 12. 2 times by 5 is 10. 10 times by 4 is 40. Can we simplify this? Divide them both by 4. 12 divided by 4 is
3/10.
okay, lovely. Done. Okay. So do you get the idea of this kind of question? Even though they got like, parts of the tree diagram not drawn. Okay, that's the end of these samples that we're going to be doing this to warm us up for the topic. We're going to have a short break now, followed by examination questions, and that'll be made in a different video. So we'll do just pure exam questions next. Alright? Are we ready for that, folks? I will be looking at also probability without replacement as well in those videos.